If you process data in R using standard for loops, your computer reads and executes each item sequentially, one by one. The apply family of functions replaces that slow line-by-line crawl with a single sweep across your entire dataset. This is a standard two-dimensional matrix. To process it, we use the base apply function. It takes 3 arguments. X is your target data, fun is the function you want to execute, and margin tells R which direction to travel. By setting the margin argument to 1, we direct the function to calculate row by row, extracting the maximum value from each horizontal row. If margin changes to 2, the operation pivots. The function now runs vertically, pulling the maximum value from each column. Controlling how you explicitly target rows and columns with this indexing logic is the first step to writing clean, scalable R code. 2D matrices are just one structure. Dropping to a one-dimensional list, you lose rows and columns entirely. That requires a different tool, lawApply. No matter the input data, lawApply guarantees returning another list. The outputs drop into separate, strictly walled-off box segments. Those walled-off boxes become an obstacle when you need to calculate simple summary statistics. If you need to plug an average into a math equation, you need a continuous, flat vector of numbers, not a collection of nested lists. This is where users turn to sapply to simplify the list into a flat vector of numbers. But sapply guesses the data type. One unexpected character makes sapply silently coerce the entire vector into text strings. Downstream calculations immediately break. Sapply is a helpful convenience function for quick checks in the console. Because its output format is entirely unpredictable, it shouldn't be used in production scripts where data integrity matters. To get a flat vector safely, we have to remove the guesswork. We do that using vapply. Vapply requires a third argument, fun value. You explicitly declare the output type you expect, like a single numeric value. This acts as a rigid mold. If a text string tries to slip through, vapply forces the script to halt and throw a clear error. Let's test this. Pause the video, write a vapply statement taking a list called words, counting characters with the nchar function, explicitly returning an integer. The correct syntax is vapply words nchar fun value equals integer 1. By forcing the output type to be an integer upfront, you ensure that messy input data can never silently corrupt the rest of your calculations. While vapply is the safest option in base R, the Purrr package has become the modern standard for functional programming, relying entirely on its map functions. The transition from base R to Purrr is a direct one-to-one translation. lapapply directly translates to the standard map function. Both reliably return a list. But Purrr improves on vapply by baking the strict output type directly into the function name. Instead of writing out fun value equals numeric 1, you just use map doubly. For text strings, you use map charlie. You state your required output type right in the function call. Anyone reading the code knows exactly what type of data is being returned, and unexpected data types are immediately rejected. These choices clarify exactly when to use each tool. Process matrices with apply. Use lapply or map if you need a list, and use vapply or a typed map function if you need a vector, and completely abandon sapply. Relying on explicit, strict output types replaces fragile loops with code that handles errors predictably and prevents the type errors that cause legacy scripts to crash.